Bueno, hola a todos. Soy Fran Ramírez.
My name is Fran Ramirez.
Y a ver si podemos saber cómo los chicos malos pueden.
So how easily the bad guys can F the world? Well, because we can't say F plus the rest of the word.
Lo que vamos a decir aquí es
Legal notice.
para que
This is to practice so that you can learn. Don't be bad.
así que vamos a ir poco a poco.
So we'll go little by little. Who am I?
Yo soy Fran.
I'm Fran. I work in Telefonica and 11 Paths.
Ciberades.
I have a blog called Cyberades, and I speak about freak IT, and I have a book about micro stories and history of IT, archaeology in IT, and all these topics. This talk, well, I've given a presentation with Pablo González Pérez, a colleague of mine. He's an ace of security, and we've always modified this talk in order to adapt to the various events. And now, well, I didn't want to tell you about this, but anyway, this happened to a friend of a friend of a friend in a university that I won't mention. At the time, the operative system practices were done on this type of computer with nothing inside, not even a hard drive. And one day, let's change it, they said. We'll give you a display, and this is what we got. Now we're going to change it again. A bigger screen in green. So we were just blind. In the room, it was full of PCs. A friend of a friend of a friend of mine said, yesterday, well, this was the only machine that was there, and there was a diskette driver. The other terminals had just a screen. So this friend of a friend said, well, if we can put a keylogger, because we wanted to finish our practice and use this PC, put a diskette in it, and then download whatever we could. This friend of a friend started to think, let's do it. In 1997, to do a malware or to make a sophisticated program, it was very complex. You needed to read a lot of books. You needed to read these 4 books at least. And this book that you can see here is DOS undocumented. It was a real revolution at the time. But you have to read the books. You had to study the books. And you got into the BBS, the old BBS. You don't know what this is, but the BBSs, and you knew people there. So this friend of a friend of a friend, this friend said the PSP, it was the MS2 key logger for in Spain at the time. Let's insert a code, and in order to do that, it took him like 3 months to do that. Today, you don't need that. You just need what's in there, Google. You go into Google and you say malware. I want to make a Trojan code, and then you can have it immediately. In 1997, these were the 2 types of hackers. Well, no, I said hacker, but it's not the right word. These people were malware creators. On my right, that was a hacker. On the left, I don't know, but it's a good photo. It's great. The looks. You know the person on the right? Who's that? This guy is Robert Tappan Jr. Morris, the only person who destroyed the internet. He broke our ARPANET in 1997. That was the old internet. In 1988, he broke it because he created a Mortally Worm. He was a great impact. And the IT Third Response Center was created after him. The malware authors at the time, well, people thought there were these kind of guys on the left, but this guy on the right was a real profile for malware creators. He's dad was a big fish in harbor net, so he knew what he was doing. But this worm, he didn't make it to break the internet, but to show the SMI protocol failure. In fact, it was a chain. The worm was inside, but he didn't check if previously it was already copied in the micro, so created a DOS. It was a service denial attack, the first in history, and he broke down all the ARPANET servers. So this guy had a very technical profile. He knew what he was doing, and he created this malware. But today, this has changed. Creating a malware was like reading books. But today, anybody can create a malware. We're going to demonstrate this here. Just, you have to look for the correct information in the correct places, because everything is in the internet. We have websites like Flu projects, Exploit the Bee, Exploit Database, GitHub. You'll find anything there. You'll see that now, because you need to do like 4 searches and you'll find anything. So my idea here was to demonstrate how easy it is to create a malware. Like if we were playing Lego, it's like pieces of Legos, and let's do a ransomware. We take a piece. We need to have a code exploiting a vulnerability, for instance, for overseas. Well, pick the pieces. It's so easy. Play Lego. Just assembling pieces. So we think that there are 4 keys for any malware. These 4 pieces: propagation, persistence, privileges, and spying. Propagation is vital. It's the only way for this malware to survive in the environment where it was to propagate and expand. Persistence, it's being there and not moving, about the fileless technique, trying not to be in the equipment. I execute myself, but I'm not there. Privileges, the machine, well, who's executing it? Who's got access? What user has administrator access? What about this process? We need higher privileges that are possible, and spying to take advantage of that information collection against that machine. So we need something in exchange. I'll elaborate on propagation, because many people have spoken about this already, but I'll give you some background. Propagation. First, well, this is about the background. The first virus in history appeared in the Apple II computer. It was propagated via floppy disk. You don't even know what a floppy is. This is a floppy. It was the only method for propagation that existed at the time. It was 1981. The first virus was called Cloner. In the startup section, people needed the floppy to start the machine. This was the propagation method. Today, the expansion method is the internet. In the past, we needed this type of diskettes. This evolved, and Blaster appeared, exploiting a security failure from DCOM RPC. It's a vulnerability service. Then SASA, it was a very bad worm. It was really bad. The LSAS, it's buffer overflow. This deals with the whole security policy in the machine. So it was crashed, and then the worm infected. That was in 2004, and today, Eternal Blue. It was an SA filtration. It was an SMB error. It was categorized as CVE 2017-0144. It's been modified and it's been transformed into different virus, cry, etc. So let's talk about the CVE. It's so easy to do a propagation using the email. which is the virus propagation method, which is the best for impacting machines. But there's another one which is better than email. This error, this infection system, was about sending a victim an email with a Word file. So you click on it, and the payload executed immediately. How do we do that? We sent an email with a TTF Word file, which just had a Gold2 file embedded. To do this, we needed a small server, some of that's here. I don't know if you can see it. I'm calling it a server just to give it a name, but it's the infection server. You put it there, and you start generating files to infect. I create an HTA file, which is really just an HTML file, but the A means application. What that means is that the browser, in this case Internet Explorer, is going to run it as an application, not as an HTML file. This HTA file has a standard base. Where you see it contains payload is where we include our payload with Metaxploit. And in Metaxploit, there's an app called MSF Venom, and it just generates all kinds of payload, any kind of payload that you want to add. And it generates a code, and that's what you insert into the HTA file. What you can see below are the parameters. The most important are the IP of our host, that is our server that is waiting, the port, and the type of file format. In this case, it's pWindows 64. So we come back to the HTA file, and we include it there. You haven't got the whole code, I've just put some of it. We put it in the HTA file, and we give it a name. In this case, I'll call it Fire HTA. So we've got the payload in it. And the next step is to create an RTF file, a Word file, and inside it, what we do is put the two files where the user is going to run it. But then we put the two files in the server before that, so the cache FTL actually looks like a web.dat. So we have to run the A2nmod file, which installs modules. The Apache file is then by default modified so that it appears like a Word or an RTF file. Then there's the final step, which is to get the Word file that we generated at the beginning, and inside we put our web address, creating the payload in the Word file. And for this to be run, with this a double click, we have to modify it in the notepad on a flat text. We look for the update variable, and if it doesn't have it, we add it. So as soon as you double click, the malware will work. And to finish, what we did was to unify everything with the cache file, the HTTP file, and then we add it to that file. And all you've got to do is wait until the victim does a double click on that file. And as soon as he does, it installs a reverse shell. This has been used in a huge number of different malware. For example, Drydex was a bank trader that used spam that was extended, and it was included in a Russian spy manual. All of this is this year. The same goes for latent bot. There's all different kinds of version. And the most recent is a variant of what I just explained to you before, but in this case in PowerPoint. So, earlier I said that it was aimed to spread to email. But we thought, okay, maybe there's a bigger vector than email, which is Twitter. Twitter has a checking mechanisms. It has a small blacklist. If you put a URL in a tweet, it can't check everything, although even though there's a blacklist. Let's just imagine. I don't know who you think has more tweets in the world. It's not a Nobel Prize winner or anybody. The person with the most followers in the world is Katy Perry. She's got 106 million followers, followed by Justin Bieber, Barack Obama. There's not many scientists there. So 100 million users. Imagine the impact. If you can steal Katy Perry's account, her Twitter account, and you can put a tweet which says, I'm going to leave the world of music and I'm going to join Scientology. Here I've got a word file where I explain everything. Imagine 106 million go click on that. If they do that, and if that leads to malware, you can infect 106 million users, not just in PCs, but also in smartphones as well, in an Android, in an iPhone, or whatever. What we wanted to do is try it. We thought, oh, this is true. Let's see if I can do this. So we created a fictitious Twitter account. We created we gave it a general address. We published a couple of tweets. And here, if you double click, and nobody says anything. So you download it, no problem at all. You can see how it's going to run. This makes it think that maybe Katy Perry should have somebody controlling her Twitter account. But it's a very dangerous issue, and it makes you think. So that's as far as we're going to go with spreading it. Let's now look at privileges. During this event, people have talking about UAC. You all know what a UAC is. It's like every time you run a program. I think it actually came out with Windows Vista, this UAC. And to get a privilege, what you have to do is you try, because what a UAC does is it allows us to run programs with an account that isn't the computer's administrator. Usually it's always going to ask you through this window. So the UAC, what it does is it goes round this operation, but it only works if the user is within the administrator group and hasn't by default affected the UAC policies. So there are WinElevate and UACME and others. There are different plugins. And if we mix UAC with a fileless, then we're doing things a little bit more technically.
Por eso vigila siempre esa rama que veis ahí del.
That's why you have to be very careful about that.
Bueno, el último es una escalada total, que es una
And the final is a total scale up where you get 3 faults in a row. This isn't really a USC, but it's there so that you can see it, so that you can get access to the machine's privileges. If you really want to know about UAC, this year, my colleagues Santiago and Paulo are going to be talking at the Black Hat, and they're going to be talking about guacamole.
Eso es una herramienta que se dedica a ejecutar plugins para saltar y probar todo tipo de UACs.
And what it does is it trials all kinds of UACs. Try that.
Aquí he vuelto a usar Office.
Here, once again, I'm using Office because everybody uses Office, and it's the best base for trying these kinds of malware.
Keybase es un tipo de malware.
Keybase is another malware which uses Excel documents, but it asks you things. You've got to activate macros. If you want to run this file, and of course everybody does, you've got to be able to see it. And it says, please click Enable Content to view protected document. And so what they're going to do is install a malware. When you do this, a hidden instance of PowerShell starts up. Then it downloads a file called my.exe from a remote server, in this case a Russian one, which keeps it in a temp system and changes its name. And there you can see all these branches that I told you to keep your eye on before. There what you do is you write down these binary files, and once you've done that, it carries out a query, and it runs the malicious file, does the bypass of the UAC. Here you can see it in more detail. I don't know if anybody can see it from the back of the room here. I've used EBIT analysis, where you can see in detail how it gets, how it puts everything in there, the hidden PowerShell, the login branches. It explains how it's done. Right? Espionage. This was the final of the 4 characteristics of malware. What it does here is it makes the most of what malware doing. So you've got RAT here, remote administration tool, which always have command and control. It can activate all sorts of things, the web camera, what the malware does. Here you can see all the different options that it allows you to do, which virtually all malware that have a CNC, command and control. The one that has the greatest control is Mariposa botnet. Mariposa botnet infected 12 million IPs, unique IPs, that 12 million zombie computers. Zloader. I'm still using Office, so just so you can see how easy it is to use Office to infect a computer. Zloader was another botnet which had its own CNC, and it did the same thing. Activated the user, so it encouraged the user to activate macros. And this macro used a CNC to download the payload. It looks similar to the previous diagram, as you can see, this with the Zloader. and the malware. And when run it, the user activates macros without realizing it. It calls our rogue server. And what it does, injects into the user as soon as he opens a specific bank page to get and to fake the web connection of this bank. This is specifically for bank hacking, for users that have got internet connection and access their bank using it. I can't talk about malware without talking about ransom software. Ransom software is very, very simple. It's perhaps the easiest part of malware to make, because it's just an algorithm which just encrypts a file with a key that can be used to decipher. There are lots of methods. For example, hidden tier. There you've got the link which explains step by step how hidden link works. So what do we do with all of this? Let's go back and just have a refresher look. We've got spreading, persistence, privilege, espionage, and ransomware, if we want. Let's concentrate on the first four. How can we bring all these together to create our own monster, our own Frankenstein monster? So how can we take codes from different areas to make your own Frankenstein monster? We started looking at it, and we started thinking about GitHubs. We always think of GitHubs. And GitHubs, you can find all sorts of things: exploits, ransomware, keyloggers, spyware, Trojans. And we thought, okay, how about if we connect GitHub, we download code, we compile, we download code directly to some kind of service which will analyze if we've got malware or not. It's perhaps VirusTotal. And if you look at the bottom there, I don't know if you can see it, it's just a simple query from the website of VirusTotal. I think I'm going to zoom in so you can see it. And here, what I'm doing is searching for Trojans. Find that Trojan for me. And if you search for Trojan, it's in 159 codes in Python. That means there are 159 repositories in GitHub that talk about a GitHub and then about Trojans. And they're not anti-Trojans. They're Trojan codes in Java, in C++, in C#, in virtually all of them, except for some odd language like Ensembler. It's full. Or you just got to seek Trojan. Imagine if you're seeking for a different kind of parameter. So we decided to automate this malware construction process. But is there lots of malicious code? Yes. And anybody can access it. So how do we make a POC? How can we get hold of this? First thing you have to do is to find a keyword and the language that we want to implement. For example, you try to find different code bits. But then you need to get a function to call the bits of these codes, and they make the call from there. You take it to the repository. You convert it into exe. You compile it, or you can leave it as original. And the next thing to do is to check whether some antivirus or any kind of antivirus motor engine can detect it. So we did that. We've got the conclusions. So we took code, Python code. Okay, let's first make a program that makes consultations with just a keyword, and we look at the language that you want to look for it in. Has to spend time doing it. And the next step is to go to this repository and compile it. So you can compile a Python code. Here we had a slight problem, and it's an interesting problem because if you compile with pinstaller any kind of thing, you'll find five possible virus. We get the impression that pinstaller calls something and detects this as something strange, but if you want to try it, it's hello world. And the next step is to check whether there's some kind of malware. These three stages, you can start finding your code. So we trialed it. We went to registro.exe. This is the hello word, actually, it's called. There you can see who found it, Sentinel-1. And then we found ransomware as well. We thought, why don't we automate it? Copying and sticking, we decided to automate it instead of copying and pasting. So we decided to make this Franken tool. It's very simple, and what it does, at the top it has a keyword that it has to search, and you say you want to find ransomware. So you find all those that include the word ransomware, and you can download it, compile it, and then upload it to Virus Total. And that'll give you a report, and you can see, yes, here there is, here there isn't. So in that way, we've got our parts of malware, and we can check that they're going to work. So imagine the potential of this. Below you've got an example. We uploaded this one here. You can find it in GitHub if you look. And it gave us 7 positives. But the ones at the bottom, none, 0 positives. So this is just an example of the reports that Franken will produce. And there you've got one positive. And now I want to show you how this works.
Vale, aquí, a ver. Vale, mejor aquí. Vale, aquí tenemos el código, tal. Un segundito, que vea una cosa. Vale, un momentito que abra la carpeta para que vean los informes. Aquí están los informes. Vale, lo ejecutamos. Vale, creo que la conexión a internet va bien. Vale, pues nada, aquí, ¿ves? Aquí pones el keyword. Voy a intentar buscar keylogger, tardará un poco en salir.
For keylogger, takes a while. And there it is in Python. We've got Bear, Ruby, Java. And while it's carrying out the search, here, this is a connection today to GitHub, looking for the word keyloader in any source code. And look at everything that you get. I can't tell you how many there are, but look, hundreds. That's already there, all of that. So if I say, okay, I'm interested in this, I want to check this one here. This one, yes, does pass the antivirus engine filters. When I've finished, I can compile it. And here you can check everything. You check the repository. And you can see there's 0 positives. And in this way, I've checked the code to see whether it gets through the antivirus filter. This filter has a collection of antivirus which are updated to the most recent second. So if it passes this control, it'll pass the control of any antiviruses and any machine in the world. This is going to generate a report here. You can see it now. This is one that we did with the Mirai test. There were several. Look at all the ones that are searching for Mirai. And here's one that was positive with McAfee. So you can see how easy it is with automated tools to deal with this process. And this is the key of the talk. What I wanted to show to you is how easy it is to bring everything together to create a virus using everything that already exists. Here's a summary of all the tests that we did, where we did all these different searches for ransomware, keylogger, eternal blue, spyware, all kinds of malware that you believe in is going to be there. There are 22 spywares in Python. How easy it is to find that. And you can create your own malware out of that. So that's what's out there. Now, as I said, anybody can create malware. You just need to know a little bit about Python programming. You've got to go up to GitHub and just create your own malware. That means that anybody can make malware. Anybody can attack you in 1,000 different formats. For example, a new infection vector is the Internet of Things, in which the Mirai botnet infects IP cameras and attacks makes a DDoS attack. But there was a subnet that it didn't attack. For example, it didn't attack General Electric or the North American Mail Service. It's interesting that it didn't attack those two. So you can see that threats don't come from anybody that comes from a malware. It could be from the CIA, which just loses a bit of code, and all sorts of things happen because this code appears in GitHub the second it's published. This effect is created by leaks such as Eternal Blue, which can expand over internet. There was another case where the shadow brokers did the same thing. They accessed and the NSA. And what can we do with all of this? Not a lot, actually. We can study, make sure we're aware, and see how the different attackers change and evolve. And what's more, there's a new kind of attack, a new technique which makes the situation even more complicated. And of course, what do we talk about here? Machine learning. Machine learning appears everywhere until you see the first formula and you think, oh my goodness, it's not easy. I'll explain to you now how you can do things with machine learning and how you can do things related to security with a fantastic tool. Now, my colleague gave a talk about machine learning this morning, and if you see it, you'll be able to understand better how we can defend ourselves by looking for anomalies in traffics in a local network. We just use techniques, machine learning techniques, and we use the NetFlow protocol to analyze the traffic, any sort of anomaly. There you can see the peaks, something strange is going on, and the machine thinks, hey, something is going on here. It's like using tagged samples. You have to know what you're analyzing. In this case, we're talking about non-supervised traffic. We don't know what kind of packets they are, but at the bottom, so you can see that it's being learned. For example, Windows Defender ATP, which is already in the market, uses advanced machine learning techniques using a process functioning tree, because it can make you realize that there's something there, and that's now all kinds of machine learning techniques are being used to struggle. What happens? We, instead of using it to defend, imagine we use it to attack. There is IA that has spent all its life trying to attack, and it's got more time and is more enthusiastic about doing it than any of us. Now I want to talk to you about an open AI, but first of all, I want you to know what reinforcement learning is. Here you can see a little action in which you attack an environment and then it comes back to you. It's like a circle on which you get the proof of what's going on.
I just love OpenAI. OpenAI was a non-profit organization, and Elon Musk, of course, bought it. I don't know if he bought it, really. No, he created an organism called OpenAI. And this shows all the problems that might appear with AI. OpenAI has a framework called GIM. GIM framework is to train AI. What's really exciting about this is that OpenAI has Atari GIM framework, classic Atari games. So you can train an AI to play Breakout with the bricks. Look for in the internet to see the evolution, because the IA starts to be trained, and it learns how to play. It's a DF. It's simulating a real person playing this game. It could be a video game, but in OpenAI with GIM, that simulates the purchase of a person in Amazon. So you see snapshots, and what you do is to analyze what you see on the screen. It's fine, fantastic. OpenAI. Well, you can play Breakout. It's a neural network, and it looks for the previous states. The ball is one position, then in another position, and it calculates the best direction to return the ball. How do I explain this? Because now I'm going to show you talks given in the DEFCON this year. They used OpenAI to set up a malware environment. Look, this is the same chart I explained before with this cycle of actions. It's very simple. The agent takes a decision, does an action, there's a process, there's a score because it's a breakout game, and there's award and observation. And it's the same loop until you get a maximum reward. That's the goal. What we're going to do now is to remove this video game environment and to insert an environment that is for malware analysis. In DEFCON, that's spectacular. With OpenAI, and they put an antivirus engine, a total virus, but in local. This antivirus engine had a lot of engines. It was composed of various engines. They created an AI. It was just a malware, and it was used to detect a potential infection. There were awards, more or less awards, if some of these antivirus detected or not the malware. The good thing is that to do the loop and look for the best way to alter code so that no antivirus could detect it, the idea was to modify the mutable code. There's a tool, LIEF, library for the instrumentation of executable files, and what it does is to create and modify the internal code It's a mutation of the code. At each step, it's changed. The memory segments are modified. It's randomly changing. The code can be modified. It changes signatures, it modifies the checksum, it modifies code sections, it adds random bytes, it injects code. I invite you to see it. I was impressed. It works fine. They started the loop, and this worked fine. It was tested for 15 hours. We have a code that is mutating and starts to enter the machine learning loop. And this AI is learning. If I do this modification in this segment, it's going to detect this, so I'm not going to do it. This AI creates the database according to the experience that it is having. For 15 hours, it worked. And at the end, 16% of the attacks were successful. In 15 hours, 20% were successful for the malware. It starts with a very small code that is mutating. The current antivirus engines were working, trying to find this malware. So for 15 hours, it worked in this virtual machine. If you implement this in an Amazon server with 50 servers, imagine what you can do in just seconds. But what this malware has learned during the attack, it remembers it. It's kept in a file. So this is stored somewhere. Imagine that this virus connects with another virus and tells it, here you are. I learned this. Use it. That's what the problems of artificial intelligence. All the information that it's learned, it's immediately transferred between the others. And it's quite freaky and it's spooky, because it's kind of a terminator or global network that it attacks and informs the others. So it's kind of an apocalypse, but be calm, be quiet. We need to breathe and start to think about it, but you have to be ready, because every day this is getting closer and closer. And I advise you, because this happened to me, I advise you to learn mathematics again. I know, it's boring, but I wanted to know how machine learning works, and I assure you that it's all mathematics. This is the AI. It's AI, you have to study mathematics every day. That's all. Thank you very much. I'm sorry if it was too much. I have a cold, and it's been quite painful to stand up here. But if you have any question, I'll be here for you. But I'll be around, so you can come and see me. I will ask you a question again afterwards. I'd like to ask you how do we open the Office document to edit it without habilitating the macros option? When we open a Word document or an Excel page from the internet, it asks us to activate the protected pieces or data. Can we use this document without habilitating the macro so that no macros can execute? No, because this Office file, in theory, the part that is interesting to you is the one that's behind the macro execution. So you will have to activate the macros to show you what you want to see, because it's behind that layer. If you don't activate macros, you will never be able to see the next level. I don't know if that's the response. Well, more or less. How do we protect ourselves against this? About stealth of these codes in Office documents. Well, the only solution is the typical solutions to have the updated programs. The CVE has a patch. Microsoft sent a patch in April, but until recently, there have been cases people don't update the programs. We always say it in cybersecurity, please update your system. It's just updating a patch. So this patch is a solution. So please update your system. So you need to update. But not everybody does it, and it's a pity.
Buenas tardes.
Hello? A question here. I'd like to ask you about machine learning. When we spoke about feedback, where the code was modified because it was learning, the conclusions after these 15 hours, what about the size of the code? Was it bigger? The file was bigger? Or the modification in machine learning comes from the code itself that modifies it so that it can be recognized? At the end, the file was the same volume, was the same size. Yes, it can be trash, but the code had a function and it did some operations. Why are you interested by the file size? You spoke about this trash code, and I want to know if the result was a normal file, jumping over all security barriers, but a big file, big with bigger size, or could it modify the authentic code? Well, they especially talk about that in their presentation. The code is not bigger, it's mutating. If a function calls for a memory segment in a specific way, it's changed and it calls it in a different way. The LIEF library analyzes this part of the code and it modifies it. They don't add new code. It's useless. It's mutating. The keyword is code mutation. The size is modified, and the variation is one more factor of detection. If there was X number of cases, it's now a bigger, something has happened in the code. But LIEF has techniques to modify and to adjust those modifications without altering the final size of the file. Have a look at the LIEF. Nobody is asking about what happened in my anecdote, a friend of a friend of a friend. No? But please don't ask.
Vale, gracias.
Thank you then.